Hello everyone, let's solve this problem completely, meaning that we should bring out all the solutions, right? Okay, so we have 2k to the power of 4 minus 32 equal to 0. And from here, it is better I divide this by 2 so that we have a simpler equation, right? So divide this by 2, divide this by 2. This goes there. In fact, you also divide this by 2. This goes there so that we have k to the power of 4 minus, here we have 16. Then this is equal to 0. Okay, so from here, k to the power of 4 minus 2 to the power of 4 will be equal to 0. And this is because we have 2 to the power of 4 to be equal to 16. Now, this is the same thing as k squared to the power of 2 minus, okay, we have 2 squared to the power of 2 equal to 0. I did this so that I can apply difference of two squares. And according to difference of two squares, a squared minus b squared will be equal to a plus b into a minus b, right? Okay, if this is the case, then in place of a plus b, I will be having k squared plus b squared, right? Okay, plus 2 squared, because b is now 2. Let's have that in the first bracket. And in the second bracket, a minus b becomes k squared minus 2 squared. And the whole of this is equal to 0. Now, let me remind you again that we are going to solve this completely, meaning that we are going to bring out the 4 different solutions. And then from here, we apply zero product rule. Zero product rule. Okay, and it says that if you have to multiply two things or two numbers to get 0, either of them must be equal to 0. Okay, so this expression is equal to 0 or this is equal to 0. That's what we are going to do. So, picking the first factor here, we have k squared plus 2 squared to be equal to 0. And from here, we have k squared plus 4 to be equal to 0, right? Now, this means that k squared is equal to minus 4. And remember that we are getting all the 4 solutions. So, to get the value of k from here, we need to square both sides. Square your k squared. Take the square root of k squared, and then we take the square root of minus 4, so that this can cancel this, and k is, by the way, we have positive or negative value on the right. K is equal to plus or minus, we have square root of negative 4. Now, let me take out the negative from there. K is plus or minus, we have square root of 4 multiplied by square root of negative 1. And then remember, if you multiply this, you will still have square root of negative 4, right? So k is plus or minus, square root of 4 is 2, then square root of negative 1 is I. From here, we have two solutions. We have k1, which is equal to 2i, and then k2, which is equal to negative 2i. So this is what we have from the first factor that we got. Now, the second factor, let's go back there. We have k squared minus 2 squared to be equal to 0. Now, let me bring that down. We have k squared minus 2 squared to be equal to 0. And from here, we will still apply our, difference of two squares method. Or if you don't want to apply difference of two squares, why don't you take this negative 2 squared to the right? So we have k squared to be equal to 2 squared. Okay, in this case, we will no longer apply difference of two squares, meaning that k squared is equal to 4. Now, to get the value of k, let me divide here. Okay, we have k squared equals to 4. So we will take the square root of both sides. Square root of k squared to be equal to plus or minus. Then we have square root of 4. This can cancel this, right? And if it does, then our k will be equal to plus or minus square root of 4. Now, k from here will be plus or minus square root of 4 is 2. And from here, we have a 2 in one solution. So we can conclude that our k, remember we got k2 and k1 and k2 before. So this is k3, which is equal to 2, and k4, which is equal to minus 2. Now let me bring the two solutions together. I mean the four solutions. We have k1, which is equal to 2i. We have k2, which is equal to negative 2i. And we have k3, which is from here, which is 2. And then we have k4, which is equal to minus 2. So these are the four solutions to the equation. But mind you, it is only k3 and k4 that are real solutions, while k1 and k2 are complex solutions. Thank you for watching.